7. A farmer is going to build a fence like we see in the picture here, and this area is along the river, so we don't need a fence up here. But the fence should have the shape of a rectangle, and the length is x, and the width here is y. And he has 1,000 meters of fence to build here, and he wants to make this area as large as possible. And so this is a optimization exercise, and the first thing we do then is putting up the formula for the area of this thing, and this is a rectangle, so it's, of course it's x times y, or a length times width, like this. And the length here is x, which it says in the text here, and the width here is y. But we can't use y here, so we need to change y in some way. And the thing is, this information here, we know they have 1,000 meters of fence, so we know that y plus x plus y, this side plus this side plus this side, is equals to 1,000, which means that 2y plus x is equals to 1,000. And then I isolate y here, move x over, change sign, and then I divide by 2, so I get y is equals to 500. I have to divide each term by 2, so I get y is equals to 500 minus 1/2 times x, right? So y here, because the length is 1,000, has to be 500 minus 1/2 times x. And then I can put this into the area formula here, length x times width y, which is 500 minus 1/2 x squared. So then we have the area as a function of x, and we can now multiply here, so we get 500x minus 1/2 times x to the power of 3. Sorry, it was not x squared here, it's just x, so then it's x squared here, right? Sorry. So there is an expression for the area, finding the area area function, and then we want to maximize this area, so we have to find the maximum point of this function. And to find the maximum points, of course, we find the derivative and put it equals to 0. And if I find the derivative here, I get 500 in the first term, and then I move 2 down, so I get 1/2 times 2, which is 1, right? Keep 1/2. Find the derivative of x to the power of 2, which is 2x. So we find that the derivative is 500 minus x, like this. So that's the derivative. And then we just have to put the derivative equals to 0. And we see that x has to be 500. And we should maybe just see that this is the maximum point, so we could draw the sine line of the derivative, which is 500 minus x, right? And this is 0 when x is 500. And since the term of x is negative, it's first positive, here is 0 of course, and then negative. So this means that the area increases and decreases, so this is a maximum point. So we know that the fence, or the area, is maximized when x is 500, and then we just need to find y, and we know that y, the other side of the fence, is 500 minus 1/2 times x, which is 500. So I get 500 minus 250, so we get y is equals to 250. So the answer here, if you want to maximize the area, then it has to have a length of 500 here, and the width should be 250, right? So x here should be 500, this should be 250, and then we see he uses 1,000 meters of fence.